All right, so in today's lesson, we're going to be taking a look at something called a piecewise function. Basically, if you think about the word, piecewise function means you have a function that has pieces put together to make one function. So I'm going to use this little intro problem here that is in your book. You can look at it if you want to. A music teacher needs to buy guitar strings for her class. At store A, the guitar strings cost $6 each. At store B, the guitar strings are $20 for a pack of 4. Use the pen tool to make graphs that show the incoming each store receives if the teacher needs 1 to 20 guitar strings. Now, if you're just following along, you don't have to use the little pen tool on your textbook. But let's take a look at what happens if store A is the one that she uses. The income for each store A receives $6 each one that she buys. So we're going to let this be the number of string packs that she buys here. So I'm going to just go ahead and I'm going to count up to 8 here, but it would keep going forever if you needed it to. And then over on the y-axis, we're going to use let's use just 6, 12, 18, 24, counting by sixes. Now that might be a little bit tricky when it comes to looking at store B, but we'll figure it out. So you've got, if she buys 1 pack of strings, store A makes $6. If she buys 2, they make $12. If she buys 3, they make $18. If she buys 4, they make $24, and so on. Basically, you have a y equals $6 times the number of strings, x, number of packs of strings. Store B is a little different, though. Store B, the guitar strings are $20 for a pack of 4. So even if she wants to buy 1 pack, she has to buy a pack of 4 no matter what. So at $20, that means store B would be here all the way up until she gets to 4 packs. Well, let's say she needs 5 packs. Well, she'd have to buy a pack of 4, and then she'd have to buy another pack of 4. So that would put her at $40. So the other pack of 4 would be here at $40. So notice as you go up, you have these different steps, so to speak, for the store B, and you have a pretty constant rate for store A. Depending on how many packs you need to buy, one of the stores is going to be better than another. For instance, you can see if we're buying 7 packs, that's $42 at store A. But it would be better because it would only be 40 and we'd get an extra pack at store B. So pay attention to that, because in life you have things that show up like this, where one of the stores is a little better than the other here, but the other store is better if you're here or here. But then the other store switches and then it's better here and here, right? Or here and here, excuse me. So when you look at that, that is what we're talking about. When we talk about a piecewise function, we would want to use one of these in a certain situation, and we'd want to use the other one for other situations. So let me show you what I mean by that. I'm going to connect it with a little line on here. Which one would be better here at the beginning? It'd be better to use store A from here to here. And then it's going to be better to use store B. Then it's going to be better again to use store A again. Then it's going to be better to use store B. So notice we have these little pieces of functions. We use this one for a little bit, then we use this one for a little bit, then we use this one for a little bit, and we use this one for a little bit. And so it creates what we call a piecewise function. Now, I know this one is not extremely pretty. Mr. Harrison's drawing skills again come into play here. But that's what we mean, and that's what we're talking about today in today's lesson, is a piecewise function. So I'm going to rely heavily on the book's drawings for these just because of Mr. Harrison's lack of drawing skills. But here's our first example of what a piecewise function looks like. Alani has a summer job as a lifeguard. She makes $8 an hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $12 an hour for each hour over 40 hours. How could you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she worked? If you look at it, step number 1 is to think about a table. When she works 20 hours, 20 times 8 is 160. When she works 30 times 8 is 240. When she works 40 times 8 is 320. That's when she's making $8 each hour. And so you end up with this first part right here that looks like this. But after 40 hours, her pay increases to 1.5 times what she was making before, or $12 an hour. So when she jumps up here to 45 and to 50 and to 55, you're multiplying these by 12. So in the first, remember, 40 hours here, it's 8 times the hours. In these here, it is 12 times the hours. So we have two pieces of two functions, okay? So what that looks like when we start to make our equation for this is that we have a change at 40 in our domain. So we have different rules for our equations. When x is greater than 40, her pay increases. When it's between 0 and 40, her pay is just the normal rate of 8 times the hours, or 8 times x. So notice also, you've got here $8 times 40, that's $320, plus the $12 times the hours less than 40, or more than 40, I should say, sorry. If you add those up, she makes $8 for the first 40 hours, $12 for anything over 40. So you have a function here for her pay that is above 40 hours. You have a function here for her pay that is less than or equal to 40, or at 0 even. And so what we have is we create this function that involves two functions in one. This is called a piecewise function. Notice right here, the key thing with a piecewise function is that over here we have the domain. Yes, that could also be written in that interval notation we talked about from 0 to 40, and then everything 40 and above. Now, technically, we probably couldn't work an infinite number of hours in a week, but the point is here at this side, anything greater than 40, you use this equation to figure out how much pay she's going to make. Any hours that she works between 0 and 40, you use this equation to see how many dollars she's going to make. So if I said Alani is going to work 42 hours. Wow, Mr. Harrison's handwriting, right? Which one of these would you use? Well, when x is greater than 40, this is how you figure out her pay. So you would do 12 times 42 minus 160. Do the math in the calculator, and I'll grab one handy beside me here while I do this. Talk to yourself for a little bit. 12 times 42 is 504. 504 minus 160 is going to be 344 So that's how much she makes if she works 42 hours. When you look at the graph of this looks exactly like we saw up here, where you have the first slope for a little while, and then it increases $12 an hour after that. So it's called a piecewise function because you have a piece of one function and a piece of another function. Notice both of those are linear because we are looking at mx plus b format for the first 40 hours and then anything after 40 hours. So you see the table at the right. The table shows how much a car rental costs per day. Use the table to write and graph the function for the car rental cost based on the number of days rented, and then explain. So what happens? Well, if 1 day is $40 and 2 days is $80 and 3 days is $120, you should see a little pattern there that breaks down right here. In the first couple days here, it's $40 times the number of days. But then after this, what happens? Well, from 120 to 155 is 35. From 155 to 190 is 35. From 190 to 225 is 35. So what's happening from here to here is that it's going up $35 every day. If you look at that, that means you have a graph basically, and I'm going to just kind of sketch one, that starts here and has got a slope of 40 at first, but then the slope kind of levels off a little bit more to 35 after that. You have two pieces of functions. Now, again, I'm not drawing a big detailed graph here. I want to show you one. I think the book has one here in a second. But let's see if we can figure out the equation. So if the number of days is between 1 and 3, technically you could also put between 0 and 3, but nobody's going to rent a number of cars for 0 days. But this is probably what your book is going to show you. Then that means it's $40 times the number of days. So the rental, I'm going to put a big little bracket section here. The rental for any function of days is equal to 40 times the number of days for the first 3 days. After that, though, it's $35 a day after those days. So think about what we saw in the last problem. When we looked at the last problem, they said if you have the first 3 days times $40, and then you have added to that $35 times the number of days minus the original 3 days, you're going to have 3 times 40, which is 120. You're going to have 35 times the number of days, and then 35 times negative 3. So 35 times 3 is going to be, sorry, brain fart there for a second. 35 times 3 is 115. 105. Golly, see, I'm struggling, guys. So 35 times 3 is 105. So that's minus 105. If you do 120 minus 105, you get 15. So if you do $35 times the number of days plus 15, that will give you how much you pay right here. So if you did 35 times 5, that's going to be 175. And then you add that to 15, add 15 to that, you get 190. So this would be the equation that I would use if the number of days is greater than 3. If I went to 4, to 5, to 6, to 7. So let's check our work, see if we got it right. Notice right here, we did the same thing that they did right here. You've got the example of the graph, the number of days here. And it gives us our solution, 35 times x minus 3 plus 120. Now, we went ahead and simplified that out, but that's exactly what we were looking at for our function as well. So the next thing we're going to look at here is graphing a piecewise defined function. So notice that from -10 to -2, but not including -2, we're going to graph a linear equation, 4x plus 11. We would probably need to make a table of values and plug in some numbers like these to give us an idea of where our linear equation is. But once we get to -2, notice what happens. With -2, when I plug this one in, it's going to actually be using this function, x squared minus 1. So as I would plug these in, I would notice that my graph would change the whole way up through here. If I plug in -10, I'm going to get -29. If I plug in -8, -8 times 4 is -32 plus 11, that's going to be -21. Then we look at -6. -6 times 4 is -24. -24 plus 11 is -13. So I would get these graphs right here that would actually be increasing all the way up. But then when I get to -2, I would use this one. -2 squared would be 4. 4 minus 1 would be 3. So notice I switched. Once I got to -2, I switched to a different function. This is why it's called a piecewise function. When I get to 2, after 2, I would keep on plugging in numbers. After I get to 2, I go back to another linear equation from 2 to 10. So remember what this is saying is this is talking about the domain on the graph. I'm going to open up the one that the book uses here. What it's saying is from here to here, you're using one equation. So your domain, -10, up to 2. -2, excuse me, but not including -2. Then you've got another graph from -2 over to +2. You're using that little graph. Plugging in numbers for x, get the points for y. Then we plug in another function after we go from 2 up to 10. So the domain, remember, the domain that you see right over here in our piecewise function is telling me from here to here, this is what the graph is doing. From here to here, this is what the graph is doing. From here to here, this is what the graph is doing. That's what all these little pieces right here are telling me. It's telling me what numbers to plug in for x because these are my domain values. So all of these are telling me what I can plug in, and it's telling me what function to plug it into depending on what the x is. And so what you end up with is, like I said, these pieces of this graph. So I'm not going to give you anything too crazy complicated, too crazy for this. So I'm not going to go through and give you way too many functions that are combined together, but I'll give you one where you've got to actually go through here and do a couple of pieces of different graphs. Notice also this one in the textbook also goes through and finds the lowest y value and the highest y value by plugging in the -10 and plugging in the +10 to this one, and it gives me the lowest y value is -29 and the highest y value is 11. So my range would be -29 up to 11. All right, so sorry about the awkward pause there in the video. Take a look at this example in your textbook. It's a video. I'm not going to play a video inside of a video, but this talks about seeing if you can find the equation from the actual graph. Also, if you wanted to try that extra example, I was just taking a look at those. That's why it was kind of an awkward silence there. If you want to try that extra example, you can. Also, there is a way to take an absolute value, like we talked about in class, and split it up into two possibilities. Remember, the absolute value can have a positive or negative possibility. And then you could split it up into two sides, your two equations. And then it gives you your two pieces that make up your V shape. I personally don't want you to do that for absolute values. I just want you to know how to find the vertex of an absolute value. So that's what I strongly suggest you do, is just find the vertex of an absolute value by doing the opposite same technique that we did earlier in the previous chapter. But you could take these and you could split it up into two different answers because of the way absolute value works. When you have a distance from zero, you have the negative possibility and you have the positive possibility. So it splits it up into two different equations. That was what actually makes the V shape of an absolute value graph. So you can take a look at that one in your textbook if you would like. The last one is very similar to the guitar strings we talked about earlier, where you have from 0 to 2 pounds a weight of something. It's $5 shipping. 2 to 4, it's $8 shipping. 4 to 6, it's $11 shipping. 6 to 8, it's $14 shipping. That creates a graph that looks like this, kind of like our guitar strings we started off the video with. These right here is called a step function. There's the bell interrupting me. This is called a step function because each one is a different level. There's no in between. Also notice if I'm at 4 pounds, I stay here. But as soon as I go to 4.2 pounds, I'm up here on the next level of price for my shipping. So take a look at that example too. I don't have the homework on Schoology yet, but I will put the homework on Schoology for this. Guys, I'm not going to hammer you hard on these when it comes to the quiz and the test because this is just a quick little section on functions and how the domain plays into pieces of functions instead of one continuous function. So these are called piecewise functions.